Hi, I am Ivy Henetti of PS in Science 3E. In today's discussion, we'll be dividing into the fascinating world of waves, covering key concepts such as wave types, mechanical waves, standing waves, and wave interference. So, let's get started!
What is wave?
Waves are disturbances that transfer energy from one point to another without transferring matter.
They can occur in various forms, such as sound waves, light waves, and water waves. Waves are fundamental to how energy and information move through the world. Waves are classified into two categories: the mechanical waves and electromagnetic waves. Mechanical waves require a medium to propagate, whereas electromagnetic waves can travel through a vacuum without the need for a medium.
Mechanical waves are disturbances that travel through a medium, caused by the vibrations of particles in a medium.
Examples include sound waves and water waves. Without a medium, mechanical waves cannot travel.
There are two main types of mechanical waves, the transverse waves and longitudinal waves.
In transverse waves, particles of the medium move perpendicular to the direction of the wave, as seen in water waves. In longitudinal waves, the particles move parallel to the wave's direction, as seen in sound waves.
Periodic transverse waves have repeating patterns over time. An example would be a sine wave traveling on a roof. The crest and troughs form a regular, repeating structure, with each wave crest corresponding to the highest point and each trough to the lowest point. In periodic longitudinal waves, particles of the medium oscillate back and forth along the wave's direction of travel. These waves have compressions, where particles are close together, and rarefactions, where particles are spread apart. Sound waves in air are a common example. Now, let's talk about wave interference. When two waves meet, they interact in a process called interference.
If the waves are in sync, they can interfere constructively, amplifying the wave. If they are out of sync, they interfere destructively, reducing the overall wave amplitude.
Standing waves are a special type of interference.
Where two waves of the same frequency travel in opposite directions. Instead of traveling through space, they appear to stand still, creating fixed nodes and antinodes.
One of the most common examples of standing waves occurs on a string or on air columns, like in musical instruments.
On a string, the ends are typically fixed and the wave reflects back, forming nodes at fixed points. In air columns, such as in a flute, standing waves are created as air is compressed and rarefied inside the tube.
The specific harmonic patterns of these standing waves determine the pitch and tune of musical instruments. And that concludes our brief discussion of waves and related concepts. Waves are everything around us, from sound and light to ocean waves and even gravitational waves. Thanks for watching.